If you watched the previous video with the notes, you should have a pretty solid foundation now for how to do questions 1 and 2, which will talk you basically through just understanding the basic shape of exponential graphs. It's important to note that these are just going to be sketches of exponential graphs, and we're not going to make really meticulous graphs because it's really hard to find a good scale for exponential things. Exponential things tend to grow very, very quickly and very dramatically. Many of us are probably kind of familiar with the idea of exponential growth now because you've been hearing about it so much in the news lately, and people have been talking about how the COVID virus essentially grows exponentially, meaning that it multiplies at such a quick rate in its infection rate multiplies at such a quick rate that the curve that you've always heard people talk about is very steep if you let it grow unchecked. So these are actually examples of the types of equations that the doctors and virologists are using to model the growth of the virus. And the exponential family of curves is actually really helpful, not just for virus measuring purposes, but for lots of other purposes. You'll be surprised how often exponential growth ends up coming up in smaller, seemingly unrelated contexts. The growth of all sorts of very natural phenomenon does happen exponentially. So let's make sure we understand it so that if you see it again somewhere in the wild or somewhere in life, you'll understand why it does what it does. Now, just to make sure I reiterate from the notes video, the structure of an exponential equation is y equals a times b to the x, where a is what we call the y-intercept, or the initial value, and b is what we call the multiplier. So if I look at the structure of the equation, I see 2 in the spot where a is, so that means the y-intercept of this graph is going to be 2. If I go to the y-axis and just place a dot at 2, I know for sure this graph is going to have a point there. Now the multiplier is the number inside the parentheses, which is 8. All I really care about is the fact that 8 is bigger than 1. I don't really care that the number itself is 8. I mean, that's cool, but all I care about is what the shape is going to look like. And when the curve, or when the multiplier is bigger than 1, and I'll go back to my notes to verify this, when the multiplier is bigger than 1, we have an increasing curve. Increasing means it starts out flat on the left and curves up as we go to the right. So that means as I draw, I'm going to start flat, close to the x-axis, and then curve up. Definitely take some time to pass through the point that you've already put on the graph. Some people do consider labeling. I know the instructions say to label, so it may be a good idea to label it just because otherwise we're just sketching and it's not really like we're making a bunch of precise points. So generally, with your sketch, you're really only doing 2 things. You're looking at where the y-intercept is, and obviously graphing that. But then you're just looking at the multiplier and asking yourself, okay, is this going to make it increasing or decreasing, and sketch accordingly. If you like to be thorough, arrows on the ends are a good idea just to show the graph does keep going. Letter B, very similar, so hopefully you've kind of known what to look for here. The y-intercept is always the initial value or the number outside the parentheses. The multiplier is the number inside the parentheses attached to the power of x. So I'll make an inference here that the y-intercept is 8. So I'll go 1, 2, 3, 4, 5, 6, 7, 8 on my axis, or y-axis. If you want to label, that's the 0.08. And now I'm looking at the multiplier, and I see a multiplier that is less than 1. So this time I need to again consult my notes and check. When we have a multiplier less than 1, that would be a decreasing exponential. So that means when I sketch, I'm going to start out up high, pass through my y-intercept, and then flatten as it moves to the right. It's hard to know exactly where to start flattening because this is just a sketch, so you can make it a little steeper, a little wider. It doesn't really matter. As long as it's pretty obvious that the graph does start to flatten out and get close to, but not touch, the asymptote. See if you can practice in letters C through E, identifying those 2 main ideas. Where's your y-intercept? Plot that point first. What's the nature of the shape? Is it increasing or decreasing? And that'll tell you what kind of curve to draw.